quadratic equations is by using the zero product property. So we're going to use that's what we're putting in our notes, use the zero product property, which really just says anything multiplied by 0 gives you that product is 0, right? So 0 times 100 is 0. 0 times negative a million is 0. 0 times x is 0. 0 divided by 0. Technically, you can't divide anything by 0. That's right. Open up a whole controversy there. All right. So the first example we're going to go over is really just problem 1 on your worksheet. You guys are not doing the odd ones. So we're going to start with y plus 6 times y minus 4, and it's set equal to 0. So it doesn't look like a quadratic equation right now, but how do we know it's a quadratic equation? Anybody know? The 0, well, technically we could have x plus 3 equals 0, right? And that would not be quadratic equation. X squared minus number, well, we don't have an x. Ah, very good. Julia said if you multiply these, you're getting a quadratic equation. Really, the only one we have to look at is this y times y. Y times y is going to give us y squared, right? That's what makes it a quadratic equation. So, zero product property. So what I want the left side equal to 0. So what could I plug into this first grouping symbol, this first factor, to make that factor equal to 0? 0 plus 6 is not 0, so that would be 6 times y minus 4, not necessarily 0, right? What number do I need to multiply y by 4 minus 4 by to get 0? Well, I could, if I plug 4 in here, right, then that would make this factor 0. And 0 times y plus 6 would give me 0. So that is one answer. If I plug in 4 minus 4, so 4 minus 4, I get 0, right? So that one would work. And what can I plug in over here? Right, the negative 6 plus positive 6 also equals 0. 0 times y minus 4 gives me 0. 0 times y plus 6 gives me 0. So this is not how you're going to show your work for this, but that is the principle that's based on. How we're going to show our work for it, and how we're going to find the values that will make each of these factors equal to 0. So we're going to set each of these factors equal to 0, and then solve. So we want to know what will make y plus 6 equal 0. We want to know what will make y minus 4 equal 0. Because if either of these factors is 0, then our y is 0. Writing, not just drawing, also writing for my drawers in here. Go write some math, do some math. All right, so now I'm going to solve by subtracting 6 from both sides, and I get y equals negative 6. I'm going to add 4 to both sides, and y equals positive 4. So my solution to this equation is negative 6 and positive 4, which we knew before we did this. But sometimes there'll be factors that you are going to need to solve. So we are going to make sure that that is a step that we show in all of our problems. Make sure that you're showing this step where you actually solve this equation. When kids don't go through these steps, a lot of times the sign will be wrong. So we want to make sure that you're showing your work for that. Anybody questions on how to do 1 through 6 then? We have more time, I think, than first period. Let's look at number 5. So there's two factors here. Is this a quadratic equation? How do you know it's a quadratic equation, Claire? The d times d gives me d squared, right? Quadratic equation has an exponent of 2 on a variable. So d squared, so that's going to be a quadratic equation. But right now it's written as two factors, d times d minus 8. So the product is the answer to a multiplication problem. The factors are things that you multiply together to get that product. These factors we just did. What can I plug in for D to make this entire equation equal to 0? Anybody? Edie? 0 is one thing, right? If I plug in 0 here, 0 times D minus 8 equals 0. And Clarence says positive 8. Well, 8 minus 8 does give me 0. 0 times D would be 0. So those are solutions. You're going to show me your work. You're going to set each factor equal to 0 and then solve, and only solve if you need to. Here, this one's already solved, right? But here, we need to add 8 to both sides. And now we know that the two solutions, the two things, if we plug them into this equation that will make the y 0, are 0 and positive 8. All right? Any questions? All right, we're going to do a couple of problems from the next section, solved by factoring. Well, we learned like 4 different ways to factor. Right? The very first step to all factoring we learned first, and that's pulling a greatest common factor out. But then we learned how to factor trinomials with different kinds of coefficients on A. We also learned how to factor 4-term polynomials. And we also learned how to factor special products. So this looks pretty simple, solved by factoring, but that could be a lot of different things. So we're going to start with number 7, n squared plus 2n minus 15 equals 0. So this is an example of how many terms does this left side have? 3. So this is a trinomial expression on the left side. It's quadratic, so we have an n squared here. It's in standard form. Remember, normally when we're factoring, we want it in standard form. Remember, standard form is ax squared plus bx plus c equals 0. Before we start factoring anything to solve, we want it in that form and we want it set equal to 0, right? So we are going to go ahead. This one happens to be in that form. When we factor anything, we always want to double check there's not a factor that we can pull out of all the terms. This has a coefficient of 1, 2, negative 15. There's nothing we can pull out of all of these terms. The strategy that we should use here to solve this, we're going to solve by factoring, which means we have to factor this part of the expression, right? So this is a trinomial with a coefficient of 1 on that quadratic term. So we learned a special strategy for that, and that is that if this is factorable, and since they're asking us to solve it by factoring, it should be, we can factor this trinomial into 2 binomial factors, and that's assuming it's not a special product, and it's not. It's not a perfect square trinomial, it's not a difference of squares. So we're going to use the method we learned to factor these particular kinds of expressions. And all that is, we know that what goes in this first spot of these binomials? We need something times something that will give us the first term of this trinomial. And very good. Now we're going to look at the constant. So the constant is negative 15. I need the factors of negative 15, which just means I need one positive factor and one negative factor. I need the factors of negative 15, and when I add them together, I'm going to get a positive 2. So there's only 4 factors. On this assignment, normally I made you list all the factors. I'm not going to make you list all the factors this time. If you know the factors without listing them, that's fine at this point. These are going to be factors that work. They have a difference of 2, right? Could be a difference of negative 2, though, or a difference of positive 2. 3 minus 5 is negative 2. So 3 minus 5 is negative 2. And negative 3 plus 5 is positive 2. We need a positive 2, so we want the sign on the 3 to be negative. We want the sign on the 5 to be positive. And all that means is, now this is minus 3, and this is plus 5. There are videos from when we covered it the first time in Canvas on how to factor with steps. If you want me to help you locate those on Canvas, I can do that. I may try to do that and list them in Canvas if I have time today anyway. So now we have factored this quadratic equation. We haven't solved it. What do I do to solve it? Ari, what do I do to solve this quadratic equation now that I have it factored? Not in times 10, so let's go back here. So here, it's factored, right? What did I do? These are the steps here, right? So I have y plus 6 times y minus 4, so I set y plus 6 equal to 0. I set y minus 4 equal to 0, right? So let's go back over here and look at this problem. So what am I going to do here? What am I going to write? N minus 3. Perfect. Good job. And what's the other one going to be? Perfect. And now we solve. So I'm going to add 3 to this side, and n is 3, and then subtract 5 from this side, and n is negative 5. So I'm going to write it in solution set notation, or set notation, doing negative 5, positive 3. Any questions? So there's all the examples of all the kind of factor are in this assignment. So let's go ahead. I think last period I did. Oh, I did number 17. So let's look at number 17. So this is your another example you have to have in your notes to get credit for your homework. 12y squared plus 40w equals 7. So remember, before I can factor it, it needs to be in this form. What do I need to do to get this equation in standard form? Riley, what do I need to do to get this equation in standard form? So 1 equal to 0, right?
I think that W is supposed to be a 1.
It is, thank you. Good job. Alright, so what am I supposed to do to get it equal to 0? Riley? It's equal to 7 now, and I want it equal to 0, so what could I do?
Minus the 7 from the other side.
Beautiful. Subtract 7 from both sides. That's right. So 12y squared plus 40y minus 7. Now it equals 0. Now it's in standard form. This equation does not look like the last equation. What's the difference between this equation and the last equation? Anybody see anything of importance? Yeah, so here A is 1, you mean, right? So here A was 1, but here A is not 1, right? So A is 12, and we're going to need these anyway. B is 40, and C is negative 7. We don't actually need the B on these, but we do need the A and the C. Because A is not 1, we have to factor by grouping. So the strategy is factor by grouping, and before we can do that, we have to split it into 4 terms. So we're going to split the middle term. You didn't use your work stretch paper, do you? Oh, you got it. Okay. Okay. So in order to factor by grouping, we need 4 terms, and we only have 3. So now we have to split the middle term. So splitting the middle term, anybody remember how to do it? Or how to factor by grouping if you get a trinomial? It's so awesome. Yes, multiply A times C. So we're going to multiply A times C. So A times C is 12 times negative 7. So A times C is negative 84. So this is the factor we use to split the middle term. So we need the factors of negative 84, that if we add them together, we will get 40. And then we're going to rewrite this and split the middle term into 2 terms. So something plus something's got to equal 40y. So factors of 84, one's negative 84, one's got to be positive, and one's got to be negative because it's a negative product. That's the only way to get a negative product. Anybody think of the factors off the top of your head that would give us a sum of 40 and the product of 84? Well, it's not 1 and 84. How about 2 and 42? Yes, because one's positive and one's negative, right? So I need, as a positive 40, so I need my smaller one, that negative 2 plus positive 42, so negative 2 plus 42 would give me positive 40. So now I'm going to rewrite this as 4 terms. I'm going to split the middle term. The first term and the last term are going to stay the same, but the middle term we're going to split into 2 terms that have a sum of the original middle term. So negative 2y plus 42y equals 40y. The 12y squared stayed the same, the minus 7 stayed the same. I've not changed the value of my equation, I just changed the form. Now that we have 4 terms, anybody remember how to factor by grouping? Julia does. Do you remember how to factor by grouping, Dynasty? Well, this is the hint. We're going to group them, right? So to group them, what does it mean to group them? Yeah, put them in parentheses, and we're just going to group the first 2. Sometimes you have to move them around. We could switch the order. I like this order the best. Sometimes you have to switch the order around to make them factorable. I think. I don't know. We don't really ever have any like that, but. So now, these are not 2 factors. I've not split them into 2 factors. I just grouped them, right? So now I'm going to take the greatest common factor of the first group, the greatest common factor of the second group, and remember the sum of those is my first factor. That's how we learned how to do it. Now we know we need another binomial factor, and so we set equal to 0. So how do I find my other factor? You remember how to find my other factor, Dior? Oh, it is. Thank you. Good job. So that's 7, not 6. Good job, Caleb. I was thinking what I would multiply it by, right? For some reason, we do that all the time. Okay, so 2y plus 7. How do I find my other factor? Can't remember, Dior? Exactly right. She said take that first group, that first parenthesis, and divide it by the first greatest common factor. That's 100% exactly what we do. We take that first group, 12y squared minus 2y, and we divide it by the greatest common factor of that group. And when we do, 12 divided by 2 is 6, y squared divided by y is y, minus 2y divided by 2y is 1. So that is our second binomial factor. So when we solve by factoring, we're only factoring one side of the equation. The other side has to be equal to 0. And now we use our zero product property. So what am I going to do to solve from here? Caleb, can you tell me what to do?
That one, so you have to find what equals 0.
Okay, how would I do that? To show you, look at the example back here. What did I do to find what to equal 0? These are my 2 factors. What did I do with them?
You just added the same, or you multiply the same. I don't know how to do this.
So I need to know how am I going to find out what makes it 0? Right? There it says set each factor equal to 0. Is that spark recognition, Caleb? So what does that mean, set each factor equal to 0?
You multiply the 0.
2y plus 7 equals 0, right? 6y minus 1 equals 0. So now we solve those individually. We have 2y equals negative 7, divide both sides by 2. One of our solutions is negative 7 halves. We're going to solve this one. Please do not skip this step in your notes. If you skip this step in your notes, I will not give you credit. Let me just do all of your work. So 6y equals 1 divided by 6, and y equals 1/6, and we should be giving our answer in set notation. So if I plug in -7/2 here, I'm going to make this first factor 0. 0 times 6y minus 1 is going to be equal to 0. If I plug 1/6 into this factor, it's going to make this factor equal to 0. 0 times 2y plus 7 equals 0. Any questions on that? I have assigned number 22. I felt like it was kind of hard. So I'm going to do number 22 with you, but you are going to have to either do it on your own or rewrite it in your homework. I will be grading for it. Does that make sense? You're writing it here in your notes, and then you are responsible for doing it in your homework in order. Don't just say, oh, 22 in notes, right? I'd like for you to try it on your own after we've worked it together, but whatever, that'll be up to you because it'll be in your notes. So number 22. It says, we're looking at number 22. I need to see everybody reading number 22. Let's do COM. Can you use your phone to translate number 22? So number 22 says, the volume of a sandbox shaped like a rectangular prism is 48 feet cubed. Do you guys know what a rectangular prism is? What's a rectangular prism? Give me an example one in real life that you probably have at your house. A cereal box, a shoe box. Technically, this room is pretty much a rectangular prism, right? Basically, a 3D square rectangle, whatever. So a rectangular prism is like a box. They're telling us there's a sandbox, it's a rectangular prism, and its volume is 48 feet cubed. They tell us that later in the problem, they remind us of the formula, which we technically should know, like 7th grade, 6th grade. The formula is the volume of a rectangular prism is length times width times height. We know the volume because they gave us that. The next thing it says the height is 2 feet. So now we know the height. It tells us the width is W feet. We don't know what the width is. And then it tells you the length is W plus 2 feet. Oh, my bad. I want to switch that around. I want to put the width is W. See ya. So the width, that's the word there. I cannot write the width there. Is W. So what we're doing, we're going to plug all these expressions into this formula. So we're going to start with, what am I going to plug in for the V? I'm going to plug in 48. What am I going to plug in for the length and the width? Well, honestly, I'm going to go ahead and plug in this 2. I'm going to plug in the one-term factors first. Even though the length is first, remember, it doesn't matter the order when you're multiplying that commutative property. Multiplication or addition, the order doesn't matter. So we're going to go ahead and plug in the width. The height is 2 times the width is W times the length is W plus 2. So this is the height, this is the width, and this is the length. Does that make sense, Bonnie? Does that make sense, Riley? All right. So now I can solve for W. W is just like my X in a quadratic equation. That variable in a quadratic equation doesn't matter. The W, we're going to solve for W. But first, we want our quadratic equation in ax squared plus bx plus c equals 0 form, right? So I'm going to multiply 2w times w and get 2w squared. 2w times 2 and get 4w. I don't like it in that order it's in, so I just switched it around there. So 2w times w is 2w squared. 2w times 2 is 4w equals 48. Have I stumped anybody? Is everybody following me? Does that make sense to Marianne? That makes sense, Isaiah? Alright, so now I need it in this form. What do I have to do to get my quadratic equation in that form? What do I have to do, Jayla? Perfect, good job. Subtract 48 from both sides. Now I'm going to have a quadratic equation that's equal to 0. So 2w squared plus 4w minus 48. These are all, none of these are like terms, so we can't combine anything, so everything just gets listed there, right? So now we have a quadratic equation with 3 terms. Before I start trying to factor it, I'm noticing something about all 3 terms. Anybody noticing something that all 3 terms have in common? Julian and Clarence both said you can take a 2 out, right? So we can divide them all by 2. We do it's 2 times w squared plus 2w minus 24 equals 0. If we were just factoring this, we need that 2. If we're solving the quadratic equation, the only factors we need to worry about are factors with the variable in it. So right now, I can ignore that 2, and I'm going to rewrite the equation that I'm factoring and solving by factoring is this. I don't need that 2 anymore. If that were 2w, I'd need that 2. But I don't need it anymore. So now I have a coefficient of 1 here. So now I can use the same strategy that we used for number 1 to factor. Give myself 2 binomial factors. What's going to go in the first spot of both of these? W, good job. W, Ari, Clarence, Joseph, W. Now, I'm going to list the factors of my constant, where my constant is negative 24. I'm going to list the factors, but if I can think of the factors in my head, I'm not going to list them all anymore. 2 and 12 is our factors of 24, but the difference in 2 and 12 is 10, and I need 2, right? So, yeah, 6 and 4. So 6 times 4 is 24. But I need negative 24, so I need one of these to be negative, but then I also need the sum to be a positive 2. So I need 6 plus negative 4 to give me a positive 2. If I made 6 negative and 4 positive, then I'd have a negative 2, but my middle term is positive. Does that make sense, Caleb? Does that make sense, Isaiah? Does that make sense, Darius? Alright, so now I just plug in. I need a positive 6, so plus 6. I need a negative 4, so minus 4. So now I'm going to set the factors equal to 0. So what that means, Caleb? What do I do here? Nice. Nice. And now we're going to solve. Oh, I don't know why I did them together, but anywho. W equals negative 6. W equals positive 4. I would have done them one at a time normally. I don't know why I did them at the same time. There's one other problem I want to go over with you guys because I want to make sure you know what it means and see an example. I'm not going to do the whole thing. We don't have time to do the whole thing anyway. You guys caught up with me? Are you just going to wait and watch the whole video while you're okay? Alright, so last example, 25, it says write in standard form, then solve. We're not going to solve in this example, but I do want to remind you how to write in standard form if you have a bunch of terms. So write in standard form. Please stop. We are not going to solve. You do have to solve for homework. Your problem that you're doing 26 so is has a lot smaller numbers than this one, so it shouldn't be too bad. So the example is 21x squared plus 5x minus 35 equals, you're supposed to be writing. It would be a lot less tapping on your desk. I just tried to do that. If you were writing, okay? 3x squared minus 4x. So, can anybody remind me what standard form of a quadratic equation is? Nazi, can you remind me what standard form of a quadratic equation is?
Yeah.
You're not, come Nazi. Wait, let her have a chance. What's your Kenobi? If you're not sure, let's look back through our notes. You see that? So what standard form? What standard form? Look in your notes. You should have them in there. Riley, what standard form? Come on, guys. Ax squared plus bx plus c equals 0, right? So don't pack up yet. We're not packing up yet. We still have one more minute. We're going to just write this in standard form. We're not going to solve it. Well, it'll take us 30 seconds. Not since you're packing up yet, Tyler. So everything up here needs to be 0. So I'm going to subtract 3x squared. And I'm going to subtract it from its like term over here. So I'm going to subtract it from the 21x squared. So that's 18x squared plus 5x minus 35. Remember that is 0. So what we have left is negative 4x. What do I do to get this equal to 0? Well, I need a sum of 0 here. So I'm going to add positive 4x. I'm going to go over here. I'm going to add it to its like term on the left side. So now I have 18x squared plus 9x minus 35 equals 0. And now I factor from here. Your numbers are not that big. Your number 26 should not be that difficult. This one would be a little bit more complicated just because it's got bigger factors. All right.